In this video, we are going to solve exercise 9.1. But before starting this exercise, I would like to introduce some of the basic concepts. Okay, what is a sequence? A sequence is a set of numbers or a pattern that follows a particular order. Each number in a sequence is called a term. For example, I've got a sequence of even numbers like 2, 4, 6, 8, and so on. It is following a particular order, as we can see that if you add 2 into the previous number, you get the next term of this sequence. Again, in 4, you add 2, you can have the next term 6. Again, by adding 2, you get 8, and so on. So each of these numbers, 2, 4, 6, 8, these are called the terms of the sequence. The terms that follow each other in a sequence are called consecutive terms. For example, 2 and 4 are consecutive terms. These are lying one after the other. There is no gap in between them. There is no other term in between them. So that's why these are called the consecutive terms. Similarly, 4 and 6 are consecutive terms, but 4 and 8 are not the consecutive terms. Similarly, 6 and 2 are not the consecutive terms. Okay. Now, the position of term is given by writing just T. That stands for the term. And a number in the subscript that indicates the position of the term. Like if I write T1, that would be meaning as the first term of this sequence. And first term of this given sequence is 2. So that first term is 2. Then if I say T2, that would mean second term. And second term in the sequence is 4. Similarly, the third term is 6, and T4, that is the fourth term, that is 8 in this case. You see that these terms of the sequence follow a certain rule. That is known as the term to term rule. Okay, with this, we introduce another type of a sequence, that is an arithmetic sequence. It is a sequence whose each consecutive next term is obtained by adding a constant number into the previous term. For example, if I say 20, 18, 16, 14, and so on, you can see that from 20 to get 18, I need to subtract 2. Again, I need to subtract 2. Again, I need to subtract 2. So that means if you add negative 2 to the first term of this sequence 20, you get the second term, which is 18. Then again, if you add negative 2 to 18, you get 16. And adding negative 2 to 16, you get 14. And so on. This continues the same way. So this type of a sequence is called an arithmetic sequence. Arithmetic sequences are actually the linear sequences. Uh, Non-linear sequences do not have a common difference between the terms, as unlike this arithmetic sequence. Now there is another type of a sequence called the geometric sequence, whose each next term is obtained by multiplying or dividing by a constant number. Like for example, if I have 5, then 10, then 20, 40, 80, and so on. You can easily observe that I've got each next term by multiplying 2 with the previous term. So similarly, like this, and so on. Okay, I can give you another example of this geometric sequence. For example, if I've got a sequence like 1000, 100, 10, 1, 10 raised to the power negative 1, 10 raised to the power negative 2, and so on. You can very easily observe that each term has been obtained by dividing by 10. So 1000 divided by 10, you get 100. Again, dividing by 10, you get 10. Then 10 divided by 10, you get 1. And then 1 divided by 10, you get 1 by 10. That can be written as, excuse me, 10 is per negative 1, and so on. So with this, now we start exercise 9.1. Exercise 9.1. Draw a diagram to show how each of the following sequences continues and find the next three terms. Okay, for part A, if I do it like this, 5, 7, 9, 11, 13. So, and for the diagram, you can easily observe that 5 plus 2 will give us 7, then 7 plus 2 will give us 9, then 9 plus 2 will give us 11, and then 11 plus 2 will give us 13. Okay, now for the other terms, the next three terms, again, we need to add 2 to 13 so that we can get 15. Then adding 2 to 15, we get 17. And in the same way, adding 2 to 17, we get 19. So the next three terms are 15, 17, and 19. Okay, now it's part B. 3, 8, 13, 18, 23, and so on. If we observe, we see 3 plus 5 is 8, 8 plus 5 is 13, and 13 plus 5 is 18, 18 plus 5 is 23. In the same way, now we can dig out the term to term rule is add 5 in the previous term to get the next one, obviously. So after 23, adding 5, we get 28. After 28, adding 5, we get 33, and then for the third term, adding 5 another time, we can get 38. So these are the next three terms to the given sequence. Okay, now I move to part C. 3, 9, 27, 81, 243, and so on. Now, I can observe that 3 times 3 is 9, 9 times 3 is 27, 27 times 3 is 81, and 81 times 3 is 243. So we can observe that our rule of the term, which is known as the term rule, is to multiply the previous term by 3. Okay, and the same way it means when we would multiply 243 by 3, the next term of the sequence would be 729. Now again multiplying 729 by 3, we would be able to get 2187, and then further multiplying it with 3, we can get 6561. So these are the next three terms of the given sequence in part C. Okay, now for part D, 0.5 to 3.5, 5, 6.5, and so on. Uh, okay, we can see that if you add 1.5 to 0.5, you can get 2. Same pattern goes for the next term to obtain, and then the next term, and then the next term. So our term to term rule is to add 1.5 in the previous term. So adding 1.5 to 6.5, it would give me 8. Then adding 1.5 once again, it is 9.5, and adding 1.5 another time, it will give me 11. So 8, 9.5, and 11 are the next three terms of the sequence. Okay, now for part E, 8, 5, 2, -1, -4, and so on. Mm, from 8 to 5, from 5 to 2, from 2 to -1. It means we are subtracting 3 from each term. So the next three terms obviously would follow the same pattern, subtracting 3 from -4. We'll get -7. Then doing it once again, it is going to be -10. And again, subtracting -3. Uh, okay, it's not actually the subtraction. You can say that adding -3 or subtracting 3. Okay, so after this -10, either you add -3 to get -13, or saying it like this, you need to subtract 3 from -10 so that you can have -10, minus 3, that is negative 30, or that is this case, or for this case, negative 10 plus negative 3 is negative 10 minus 3, which is again negative 30. So our term to term rule can be said to add negative 3 or to subtract 3. Okay, there is a bit of uh, more confusion into this, which I've tried my best to clarify. I hope it would be clear. Okay, now it's part F. 13, 11, 9, 7, 5, and so on. Observing it once again, uh, we can see that 2 is being subtracted from each previous term. So after this 5, if you subtract 2, you get 3. Subtracting 2 once again, you get 1. And subtracting 2 once again, we get negative 1. So the next three terms are 3, 1, and negative 1. Okay, now it's part G. 6, 4.8, 3.6, 2.4, 1.2, and so on. Uh, from 6 to get 4.8, from 4.8 to get 3.6, that means we are subtracting 1.2, then subtracting 1.2 again, then again, and then again. So the pattern continues the same way. So subtracting 1.2 again, that will give me 0. Subtracting 1.2 once again, that will give me negative 1.2. And subtracting 1.2 again, that will give me negative 2.4. So the next three terms of the sequence are 0, negative 1.2, and negative 2.4. Now it's part H. 2.3, 1.1, negative 0.1, negative 1.3, and so on. Okay, from this to this, mm, to this, that is again uh, subtracting 1.2. Okay, then again subtracting 1.2, subtracting 1.2, and so on. So this part has got the same term to term rule of subtracting 1.2, or you can say adding negative 1.2. So adding negative 1.2 once again to negative 1.3, we can have negative 2.5. Then again, that would be negative 3.7. And then for the third term, it is going to be negative 4.9. So the next three terms of the given sequence are negative 2.5, negative 3.7, and negative 4.9. So that concludes question number 1. Okay, now it is given in question number 2. Find the next three terms in each of the following sequences and explain the rule that you need that you used in each case. Okay, in part A, question 2, part A. 1, -3, 9, -27, and so on. If you observe, this is a positive term, this is negative, again positive, then negative. So that means we need to multiply by a negative number. Okay. And since these are the multiples of 3, so the number should be 3. So multiplying by -3. So mm, in the same pattern, we can have uh, 20, -27 times -3. That would be positive 81. Then 81 times -3 is -243. And then once again multiplying by -3, we can have this time the positive term, that is 729. So these are the next three terms of the sequence, and the rule is obviously multiply the previous term by -3. Okay, with this, it's part B. MOTUVETH. That obviously gives the first two alphabets of the days of the week. So after Thursday, we would be having Friday. So for Friday, I should be writing two letters of Friday, that is FR, then SA for Saturday, and SU for Sunday. So the rule could be uh, the next days of the week. Okay. For part C, now let me erase all of this. Part C. For part C, that would be more handy if I write it like this: A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. Then again A, B, C, D, E, F, G, H, I, and so on. I, J. Okay. Mm. For part C now, A, then C, then F, then J, then O, and then so on. Okay. You observe, you you are getting C after A. That means you have left one alphabet B. Then after C, we have got F, this one. That is depicting that we have skipped two alphabets this time, D and E. Then uh, we are having the next term in the sequence, that is J, that has been achieved by skipping the next three alphabets. So the pattern is you have skipped one, you have skipped two, you have skipped three alphabets, and so on. After J, we are having O by skipping four alphabets. So after O, we should be skipping five. So one, two, three, four, and five. So our next term should be U after skipping five of them. It should be U. Then after U, we need to skip six alphabets. One, two, three, four, five, six. So the next term has to be B after skipping V till A, which are the six alphabets. After B, then I need to skip obviously one more alphabet. Like I need to skip seven now. So one, two, three, four, five, six, seven. So after skipping these seven alphabets, I should be getting J. So this is the next third term of the sequence U, B, J. So this is how we have achieved the next three terms which were missing from this sequence. I hope it would be clear. Okay, now it's question number 3. The term, first term, T1 of a sequence is 5. Okay. The term to term rule for the sequence is add x. That means I need to add x into it. Okay. That's actually not the uh, first term. I should not be writing it down. So the rule is add x. Okay. Find the value of x that will give you each of these sequences. Every second term is not an integer. If the next term after 5, which is an integer, I want it not to be an integer. And then the third term, I want that to be an integer. The fourth term, that is integer, not integer, then integer, then not integer, then integer, then not integer, and so on. So this is a pattern that is required in the question. So, and I need to have x being added to that 5. So if I think if 5 is an integer, the next integer, if I add from into this 5 half, that would give me 5.5. That is obviously not an integer. But again, if we add into this 5.5 another half, we'll get 6, which is an integer. So then adding this half into 6, we'll get 6.5, which is not an integer. And then again, adding half to this 6.5, we'll get 7, which is an integer, and so on. So the number x in this case could be a half. So we can say x is equal to half, or we can say that x could be any number with half, like x could be 1.5, or x could be 2.5, and so on. So I've chosen the simplest case. X is to be equal to half. Okay. After this, it's part B now, which states that every second term is a multiple of 10. Every second term. Okay. That means mm, alternate terms should be multiple of 10. Okay. After 5, if I need to have uh, this is obviously not a multiple of 5, not a multiple of 10, sorry. So to have this second term to be a multiple of 10, and I need to add something. If I add 5 to that to have 10, so that 10 is a multiple of 10. It was given in the question, every second term is a multiple of 10. That means the next term should not be a multiple of 10. So 10 plus 5, if the value of x is 5, that would give me 15. Now this is not a multiple of 10. Then after this 15, adding 5 once again, that would be 20. Yes, that is a multiple of 10, and so on. So in this case, we can say that x could be 5, or it could be any number with 5 at the units place. X could be 15, or x could be 25, or x could be 35, and so on. Like if I take x to be 15, then the sequence would be after 5, adding 15, that is 20. Now this 20 is a multiple of 10. Then adding 15 once again, this is 35. This is not a multiple of 10. Then adding 15 once again, 50. This is a multiple of 10, and so on. So x could be either 5 or 15 or 25, 35, or any other number with 5 at the units place. Okay, now it's part C. For part C, it states that T2 should be lesser than T1. Okay, starting with 5, and I need to add something. Adding something to 5 so that the next number should be lesser than 5 itself. That means I need to add any number which is negative. Like if I add -1 to 5, that would be 4. That is the second term. So yes, obviously T2 is less than T1 since 4 is less than 5. So after this 4, I need to add -1 once again as a term rule. That would give me 4 minus 1, 3. That is the third term. And obviously T3 in this case is lesser than T2. That means 3 is less than 2. So the value of x could be adding any negative number. Any number less than 0. So that concludes question 3 as well as exercise 9.1. I hope you would have liked the video, and obviously, I guess you are going to give me a thumbs up and a like and a subscribe. Please do subscribe the channel and do give me a like. And if there is some query, you may please ask. Thanks for watching this video.